Suppose we have a number a raised to the power of m, and we multiply it by that same number a to the power of n. That would be a times a m times, or multiplied by a times a n times. So in total, that would just be a times a m plus n times, or a to the m plus n. So, for example, a to the 6 times a to the 3 would be a to the 6 plus 3, or a to the 9. So what if we had a to the m all to the power of n? Well, that would be a times a m times a times a m times a times a m times, etc. And we would have n lots of those a times a m times. So in total, we'd have a times a m times n times. And because m times n is the same as n times m, then we'd have that a to the m all to the power of n is also the same as a to the n all to the power of m. So, for example, 3 to the 4 all to the power of 7 would be 3 to the 4 times 7, or 3 to the 28. And we could also write that as 3 to the 7 all to the 4. Let's have a look at these powers of 3. So 3 to the 1 is 3, 3 squared is 9, 3 cubed is 27, 3 to the 4 is 81. You can see as we go up this list, we multiply by 3 each time the power or the index increases by 1. And similarly, if we go down the list, each time the index goes down by 1, the value divides by 3. So what would 3 to the 0 be? Well, we'd take 3 to the 1, which is 3, and divide it by 3, and get 1. So what might 3 to the minus 1 be? If we follow the same rule, we'd take 3 to the 0, which is 1, and divide it by 3, and get a third. 3 to the minus 2 then would be 3 to the 1 divided by 3, which would be a ninth. 3 to the minus 3, divide by 3 again, and get 1/27th. And of course, we can check, multiplying by 3, going back up the list, these values for negative indices seem to fit this pattern. So we can notice that 3 to the minus 1 is 1 divided by 3 to the 1, or 1/3. 3 to the minus 2 is 1 divided by 3 squared, which is a ninth. 3 to the minus 3 is 1 divided by 3 cubed, which is 1/27. And so in general, we can make the definition that for number a raised to a negative index, a to the minus m, that just means 1 divided by a to the m, or the reciprocal of a to the m. So, for example, 2 to the minus 5 would be 1 divided by 2 to the 5, which is 1/32. We can also see from this definition that any number a raised to the power of 0 will always give us 1, because a to the 1 would be a, and we'd divide by a to get a to the 0, and that would give us 1. We make an exception for a equals 0, and 0 to the 0 is not defined. That's the only number that doesn't quite fit this pattern. Let's have a look at a rule for division then. A to the m divided by a to the n is equal to a to the m minus n. Now, why is this true? Well, let's start with an example, 5 to the 7 divided by 5 to the 3. You can see that's written out here. 3 of the 5's cancel top and bottom, leaving 5 to the 7 minus the 3 that have cancelled, so 5 to the 4, or 5 to the 7 minus 3. We've got to think a little bit more carefully if the value of n is bigger than m. So, for example, in here we have 7 cubed divided by 7 to the 5, and then we see 3 powers of 7 cancel, and we're left with 1/7 squared. But this does fit in because, as we've just seen, 1 divided by 7 squared is 7 to the minus 2, so we still have that 7 to the 3 divided by 7 to the 5 is 7 to the 3 minus 5, or 7 to the minus 2. Okay, let's just do a few examples to check that these ideas are okay. So here's 3z squared times 4z cubed. That would be 3 times 4 times z squared times z cubed. And z squared times z cubed is z to the 2 plus 3, or z to the 5. So we get 12z to the 5. Another example, here's 2y squared, all cubed. Here we get then 2y to the 6 by one of the rules we've just looked at. And 2y to the 6 is 2 to the 6 times y to the 6, which is 64y to the 6. Third example, 6x squared divided by 3x to the 7. That's 6x squared over 3x to the 7. So 6 divided by 3 is 2, and by the rule for division, x squared divided by x to the 7 is x to the 2 minus 7. So we get 2x to the minus 5, which we could also write as 2 divided by x to the 5. Finally, one last example, a little bit trickier. 5x to the minus 3 divided by 2x to the minus 2. Well, if we do 5 divided by 2, and then we have, again, by the rule of division, x to the minus 3 divided by x to the minus 2 is x to the minus 3 minus minus 2. And that gives us 5 over 2 x to the minus 3 plus 2, or 5 over 2 x to the minus 1.